So there we are. So all right, so I just want to show you one more of these and one more independent, and then let you have the practice exam. So so these are the. Can you do it from this chart? Let me help you. This is question number 3. Question number 3. I want to show you this one in particular because I thought it might be tricky. So question number 3. So what they do is they have you click on this icon. I did, and it pops up with this chart. And so this chart is basically a list of the different jobs. The tasks, right? Symbol A, and what must be done precedent. What does that mean? Before. Pre is before, right? So in other words, job A must be done before C, C before D, C before E, B, D, and E before F, etc. So let me draw arrows. What that means is when I make my arrow diagram, A is going to lead to C, and C is going to lead to D, and C is going to lead to E as well. All 3 of these will be 3 arrows, all leading to F. F will lead to G, F will also lead to H, G and H will lead to I. So I'm going to make it now, but I just want to let you know that's what it means, right? If it's before, if it's preceded, it's done before, you do, before C, you got to do A, etc. So now I'm going to make an arrow diagram, and those arrows are all going to go in it. Remember how to do that? So I'm going to say, okay, here's my start. I'm going to make an arrow diagram up here. There's my start. Been a while since we've done this. It was last week. Which letters can I go to from the start?
A and B.
Good. A and B. How do you know?
No precedent tasks.
What's that?
No precedent tasks.
No precedent tasks. Exactly. There's nothing that must be done before A, and there's nothing that must be done before B. So if there's nothing before them, they are first. Right? That makes sense? So A and B come first. The tasks that have nothing before them. Okay, now, what does A point to? Let me just erase these and kind of check them off as we go. So I know A points to C. So I'll say, okay, make an arrow from A to C. I can kind of rearrange this as we go. And I know C points to D, so I'll just go, okay, C points to D. Just kind of making it as we go here. And C also points to E. So I'll go, okay, there's also like an E it points to. And B, D, and E all point to F. B, well, here, maybe I'll, I don't know what to do. Maybe I'll put it down here. Points to F. B, D, and E all point to F. Or maybe I don't know what to do. There we go. So B, D, and E all point to F. Good so far. F points to G. Bless you. F points to G. F also points to H. Getting a little sloppy here. I'll rewrite it once I get it all down. F points to G and H. And G and H both point to I. I'm really running out of room. So they both point to I. Okay, and then what points to the end? That's all the arrows. I got all the arrows down there. How do we know what points to the end?
I.
Got to be I. How do we know it's I?
It's the last one. There's nothing else for it to point to.
Exactly. Yeah. Everything else is pointing to somebody except for I. Everybody else has an arrow going away from them except not I. Huh? I's right here. Not point. Everybody's pointing to him, but he's not pointing to anybody else. He's the only one. H has somebody to point to. F has somebody. Everybody else has somebody to point to, but not I. So I must go to the end. So I need to rewrite that more neatly. So let me do that. So I'll come over here, kind of, what number is this? Number 3. So number 3. So now I'm going to make it neater, and then we're going to use it to actually make a schedule. What do you got? A, B, and then C, D, E. Okay, so A, B, C, points to D and E. D and E. C points to D and E, and they point to F. To F. Enough room now. F points to G and H, and they both point to I. So F points to G and H. They both point to I, and I points to the end. Whew, there we go. All right, a little neater. Right, good. So there's the arrow diagram. Now let's put the numbers next to them. What are the numbers? A's got a 12, B's got a 16. So 12, 16. C's got a 4, D's got an 8. Oops, what's that? Where are we at? E's got a 1, F's got a 4. G's got a 1, H has got an 8. 1, 8. Was I 1? Did I see I 1?
Yeah.
Okay, thanks. All right, so we got all that. Now, let's go do what they want us to do. What do they want us to do? Schedule a project. I think it's two processors. What's our priority scheme? Critical path. I also wanted to show you one more critical path. So now, so this is getting very realistic, right? The company says, look, here's the different jobs that need to get done. Here's the jobs that need to come, and how long they take, how many hours they take, and the jobs that need to be done before them. We turn that into an arrow diagram, and now they're saying, and I want you to schedule it using the critical path algorithm. So I got to do this with critical path. Now, what does that mean to do it with critical path? I'm spitting all over my iPad here because I just ate lunch. Sorry, you probably didn't want to know that detail, huh? All right. So where was it? B was 16. B was 16. All right. So how do I, for critical path, how do I put stuff on there? Remember, that's the boxes. And we only did this once, I think, so I wanted to show you one more before I hand you that exam. You start at the end, you put 0 with the box things, and then you kind of add backwards. Remember that? You're trying to find the highest number paths. So we add backwards, go back to here. This would be, or I'll put it next to the I. The I. So every number is going to end up having a bracketed number in addition to the parenthesis number. Remember how that works? So you start at 0, kind of run the arrows backwards, add as you go. 0 plus 1 is 1. Now go up that way. 1 plus 1 is 2. And 1 plus 8 is 9. Good so far? I'm just adding backwards. Right? So 1 plus 8 is 9. Just adding backwards. Keep going. 9 plus 4, 13. Just adding them backwards. 2. Oh, wait a minute. Oh, wait, there was 2 rows. 2 also goes back to this one. 2 also, they both go backwards to this one, don't they? So how do you know which one you do? Right? Both the 2 and the 9 go back to F. You know, because F had arrows to them, so backwards they go back to F. They came from F. So which one do you do? Do you take the 9 plus the 4 to be 13? Or do you take the 2 plus the 4 to be 6?
The 9.
The higher
You do
one?
the higher one. Yeah, good memory. I'm impressed. Small little detail I said once quick, but it is important. That's why I want to cover one of these more. So everybody hear that? When there's 2 paths backwards, choose the higher. And that's important because if we get these numbers wrong, it's going to mess up all of our scheduling. So is that good? So you have 2 options. Don't do them both. So a mistake students often mess this up. This is one of the small points that people miss. So I'm trying to be as clear as I can about it. That's how I learn to be better, because I watch what people mess up and I emphasize it next time. So that really gets people. Everybody hearing me on that? When you have 2 paths to go backwards, you don't do them both. That's typically, students will go, oh, I'll just do both. 9 to 11. No, you don't do them both. You do the higher. Why? Let me give you a reason. Maybe that'll make it better. You're trying to find the critical path, the most critical path, the highest number path, aren't you? That's the whole point of this, is that we want to pick the roads that lead to the most work to start on first, don't we? So of course you want the higher one. That's the whole point of this method, is what's the highest road, what's the critical path. Okay, so keep going. Now the 13, go back to the 16. Add 13, add 16, what's that, 29? But 13 also goes back to the 1, that'd be 14. 13 also goes up here to the 8, that'd be 21. Everybody see what I did? I went from this F back 3 different roads and just added 13 to 8 to 1 to 16. Good? Now, D and E, can you do the next step? Go ahead and do the next step. Tell me the bracket on C. What's the bracket on C?
25.
Yeah, because you do the 21, not the 14. When you have two options going backwards, pick the 21. Add 4, 25. Good there? See how I had two letters, D and E. C led to D and E. So going backwards, D and E both backtrack to C. When you have two ways to backtrack, two paths backwards, that says backwards. Yeah, it's pretty scribbly. Two paths backwards. I could be a doctor, look at that. Right? Two paths backwards, you take the higher one. Right? So take the 21, add the 4. So I'm taking the bracket number, adding the parenthesis every time. I'm taking bracket number, and as I walk back, I add parenthesis. 25, and then add 12, and then it's 25, add 12, what's that? 37, and then which of these two go back to the start? The higher one, 37. There we go. So there's the bracketed numbers. That was a lot of work. And now, after all that, it's finally time to make the schedule. Let me put the 29 up here out of the way. This is 13. Now they said two processors, right? So now I go, okay, processor 1, processor 2. Let me move it down a little bit. Processor 1, processor 2. Here we go. Time is 0 here. So now let's march it forward. And, all right, processor 1. Which job are we going to start off with? How do you know whether it's A or B? Right, processor 1, at the start, first employee wants a job. Is he going to get job A or job B?
A.
How do you know it's A?
Because the bracket number is higher.
Yeah, the higher bracket number. So again, we're looking at the bracket numbers now. What does the bracket number tell me? It tells me how much all the things to the end add up to be along that path. Right? That's the whole critical path method. That's what the bracket numbers are. Right? The 12 is how long job A takes. The parenthesis number is just how long job A takes, 12 hours. But the bracket number is how long all the jobs from A to the end add up to B. It tells you how critical that path is. Right? The bigger the bracket number, the more work there is down that road to the end, the sooner you should start on that road. Right? That was the wise way to schedule. Yeah, so we start on A, not B. Now, what if they said, I want you to do this problem using the decreasing time. Remember, there's different words. What if they said decreasing time? Well, that would just be the parenthesis number. Remember, that was just the parenthesis number. So I would start with, it's always high to low. So I would start with the higher parenthesis number, which would be 16, because B is 16 higher than A, 12. In that case, I'd start with B, if I was doing it by decreasing time. But I'm doing it by critical path. Critical path means look at the bracket numbers, look at the whole path. So it's 37. So here's the other mistake students make. They'll go, okay, here we go, and they'll put A all the way over at 37. No, no, no. 37 is just the path. A only takes 12 hours, right? Right there. So A is just a 12-hour job. Don't get confused with that. So 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12, job A. So down here, this guy will do job B. 12, 13, 14, 15, 16. Job B. Processor 2 will do job B, right? And then you start moving forward in time. Kind of go dot, dot, dot. I want to get you on that practice exam. So you know the rest, right? Dot, dot, dot. Just keep working on the schedule. Is that good questions I can answer on that one? Danny. Johnny. Hey, you get my, yeah, sorry, I always get, yeah.
I figured it out, I got a little tripped up on F.
On which part?
On F.
F.
Yeah, where when you got to F, when you went from H to F.
Yeah, so it's a 9 plus 4, so
Yeah,
bracket
13.
plus 4, 13, and you mean that from backwards there?
So the 2 up there, that just
The 2 up there.
on G.
There?
Yeah.
Oh, why I didn't, yeah, because, yeah, I had two options, right? There's two ways to get back to F. This way and this way. So will I take the 2 or will I take the 9?
The 9, because it's higher.
Because it's bigger.
And then I'm
9 add 4.
After F is when I.
Okay, so now F, and now there's 3 arrows that lead to F,
Yes.
right? So I'm walking arrows, but so this one leads to F, this one leads to F, and this one leads to F. So I'm going to walk those backwards now. So F, the 13, walk backwards, add 13 to 16, 29. Now, F's going to go back to all three. This one, add 13, right? 13 plus 1, 14.
Okay.
And 13 plus 8. Add 13 to 8, 21. Make sense? So that F goes back like that. Good. Other questions on that? We okay on that? All right. Okay. All right. Let me let you start on that. How about? So I think you'll get more. Let me give you 1 minute. Just if you can get started on that. I want you to make a schedule, you know. There's a key word I'm hoping you'll see here that makes this one different. What key word makes this one different than the others?
Critical path.
Does it say critical path? It does. Yeah, that's an important word too. So I guess, what's another key word? Independent. Yeah, that's what I'm trying to emphasize on this one. Independent. What does that mean when they say independent? No map, arrow diagram thing needed. No arrows needed. Remember, that's like making Thanksgiving dinner. It doesn't matter if you make the turkey first and then the potatoes or vice versa. The order doesn't matter. Independent. They're not dependent on one another. You don't have to do the turkey before the stuffing or whatever. It's independent. So that means these jobs, whatever these jobs are, can be done in any order. That's why there's no map here, no arrow diagram, and we're not going to make one. We don't need one. These are way easier. Is everybody with me on that? So watch for that when you take the practice exam and the real exam next week. If it says independent, those are super easy. The order doesn't matter as far as, arrows. So what do you do then? Well, you just go ahead and let me put... This has 3 processors, doesn't it? You can see from the answers, they're all 3 processors. And how do you know what order to do them in then? You can do any order you want, except we do have to follow critical path. That's true. It was a good observation. That word's important too. Critical path. Now, what does that mean, critical path? High to low, doesn't it? It always means highest first. High, low. Now, I don't have to actually do the bracket numbers like I did on the last problem for critical path because I've got no arrow diagram here. So I don't have to do that. I just simply grab the highest number first. So which one of these, A, B, C, D, E, F, or G, which one's highest? B? Is it B? Yeah, B. B, it looks like B. So B is first. So processor 1 will do job B. That'll take them 1, here's 0, 2, 3, 4, 5, 6, 7. 7 hours for job B. Okay, processor 2 will do the next highest job. D for 5 hours. It'll be right here. D for 5 hours. And the next highest job, F, for 4 hours. Okay, who's the first one done and ready for a new job? Yeah, processor 3 is at 4 hours is ready for a job, another job. So what job will that processor get next? Could be C or G, right? I guess they're equal. Yeah, it doesn't really matter. Right, everybody with me? C and G are equal. So it does. I'll just do C next. 3 hours. That'll take them up to 7. Everybody see what happened there? C was a 3-hour job. Takes them up to 7. Who's next ready for a job? Processor 2, right? At 5 hours. This is a 5. Funny looking 5. Processor. Am I going too quick? You see how processor 2? So you always do whichever person's ready for a job first. So right now, so processor 3 was ready after Forrest gave job C, because that was the next highest one. And then right here at 5 hours, processor 2 is ready. Processor 1 is not going to be ready until 7. So give him the G, the 3-hour G job. So 5 add 3 will take him out to 8, huh? For the G job. What else remains? Who's ready first for another job now?
You accidentally crossed out E, so that's another 3, because you put the arrow through.
Oh, thanks. My mistake. Thank you. E. So then, yeah, and then so then we have G also. So this guy will do G, right, to 10, 8, 9, 10. G. Thank you. E and G. Like that. And then what's left? Just A. Who's ready first?
Processor 3.
3 for 2 hours. 8, 9. A. Done. So when are we done with the job? 10 hours. So this is 2 hours of idle time, 1 hour of idle time. There we go. Yeah, see how it's this answer here? Do we get the same thing? B, G, D, E, yeah, F, C, A. Yep, there it is. Yeah, thanks for the tip. I almost messed up. I was just trying to demonstrate how easy it is to mess up. I'm just kidding. It's good to count your, not count, go through your letters, A, B, C, D, E, F, G. Make sure you didn't miss any, like I just did, started to. A, B, C, D, E, F, G. That way you haven't missed any. Is that good for independent tasks? Those are easier, way easier, huh? No arrows, just high to low, no big deal. Now, there's a couple other questions. That's this right here. 10 hours is how long it took the job to be finished. Okay, that you know. And then coming in here, so they'll ask you, what's the finishing time? 10 hours. Now, look at this next question. Optimal. What does optimal mean? Best, right? Optimal means best. Very, very best. So they're saying, okay, yeah, that was a pretty good schedule you found on the last problem, but what's the best schedule? Don't waste your time on this, guys. This is super easy. Honestly, I'm not going to put this on the test, so I don't want to waste up any more time. You know which one's best? The one that has no idle time. Which one has no? He has some idle time. He has some idle time. He has some idle time. He's got no idle time. And, you know, that's just that. So anyway, what's my point? Well, that ends at 9 hours. How long did our job take?
10.
The way we scheduled it took 10. So that's actually a little better. That's optimal. That's a little bit better way to schedule it. I don't know how they figured it out, but whatever. That's a little better way of scheduling the job. That only takes 9 hours instead of our scheduling that took them 10, had a little bit of wasted idle time, right? So then down here they say, what's the optimal time? 9 hours. Yeah, we got it. And then they'll say, what's the percentage error? That's the one that's just off the screen. Let me give you that. Percent error, because, you know, our answer was not perfect. We got 10 hours. We made a schedule that took 10 hours instead of the best one, which is 9. So we're not optimal. We're a little bit of an error. How much? Here's how you calculate the error. It's your time minus optimal divided by optimal. Your time minus optimal divided by optimal. So you can put that in your 3x5 card. So let's calculate that right now. So what is our time for that first schedule we did? 10 hours. Minus what was optimal? 9 hours. That was the best over optimal. 10 minus 9 over 9, which is 1 over 9. Hit the buttons on your calculator. Doesn't it come out like 0.111s forever? Like that? And then how do you turn a decimal into a percentage? Because we have to get percentage in the end. 2 places, huh? That's why there's 2 zeros in the symbol, right? 2 places. Boom, boom. So it would be 11.1%. I don't know how many places they want you to round, but however many they asked for. There it is. So it's 11.1% error. Our answer was not best. It had a slight error. It wasn't the very best way to schedule. 11.1% error. Let me give you this fact and we'll be done. These different methods, here's the conclusion. Brute force. You remember the different methods we used for making the maps? What were they? They were nearest neighbor. Yeah, that's it. Nearest neighbor and repetitive. Nearest neighbor, repetitive. Nearest neighbor. And then shortest link, or what was it? Cheapest link. Thanks. Cheapest link. Anyway, those 3 methods. Did you know all of those methods are not the best? They're not optimal. They will not guarantee that you get the best answer. You know what we call not optimal? We call that approximate. So they're approximate, but they are fast. The word we use for fast is efficient. Whereas what is brute force? The brute force is examine or try, how about that? Yeah. Try every possible circuit. Remember this is words. Try every possible circuit. Keep hitting the little button there. Every possible circuit. Try every that's called brute force. You just look at every, remember visiting, traveling salesman having to visit all the cities to deliver the goods, right? If you try every possible circuit, that method is optimal. You will find the best answer. You will get the best answer for sure. Because you've looked at every possible circuit. You will get the best answer. But it's slow. What do you mean it's slow? We call that inefficient, because that's the official word we use. It's inefficient. Remember how inefficient is? Remember, that's the one where we calculated with the calculator that it would take the fastest supercomputer in the world, like, I don't know, 1,000 years or whatever. It's that inefficient. I mean, it's just, even computers can't do it in any reasonable amount of time. That's why we don't look at every circuit. That's why we don't just tell the computer, look at every possible circuit and give us the best one. That's why we have these other methods, because computers can do them quickly, even though they don't give you the best answer. Does that make sense? That's the conclusion to that chapter. That was the chapter 6 conclusion. That all the other methods were not best. They'll give you a pretty good answer, but not the best, approximately. A good answer that's approximately good, but they're fast. Computers can crank them out, get answers for UPS and FedEx. So brute force was the terrible method that takes too long, but it would be optimal. So they'll ask you questions like that on the exam. Yeah, and this goes also, by the way, if they ask you about any of the methods we learned in chapter 8, which are what? What are they called? Critical path. What's it called? What was the other one? Decreasing time. They're all the same story. All those methods are not optimal and they're efficient. So those questions, those will be freebies if you have that in your 3x5 card when those are on the exam. I don't remember which ones are. I'm sure there's a couple of these. Right off, these will be automatic points if you have them on your card. They're automatically, you better guess if you don't. So no, every method we've learned in these 2 chapters is not optimal, it's approximate. Notice they don't, critical path does not guarantee the best answer, as we just saw. We just did critical path, and then they showed us there was a better answer. We were in error, right? So critical path, decreasing time, none of them guarantee the best possible answer. They give you a pretty good answer. They're approximate, but they're fast. That's why we keep them. Computers can crank them out fast. Brute force is the only method, the only way to get the for sure best answer, but it's just way too slow. That's why we don't do it. Is that good? Questions on all that?